Now chapter number 2, electrostatic potential and capacitance. Now first we have to discuss the work done on moving charge in the given electric field. Okay, this particular part which we are going to discuss is not given to you in the text, but that is very important thing for this particular chapter. Now suppose as shown in the figure, you see a point charge capital Q, which one is placed at the origin of Cartesian coordinate system. Now in the surrounding of it, the electric field of this charge Q is prevailing. Now in that electric field, suppose we want to move charge small q from point A to point B. Point A have the position vector r1 with respect to the origin of Cartesian coordinate system, and point B have the position vector r2 with respect to the origin of Cartesian coordinate system. Now we want to move this charge small q from A to B. Now arbitrarily we consider two paths to move it from A to B. See here, suppose first we move it from A to C on the curved path, and then after we move it from C to B on the linear path, and we calculate the total work done. And then we will calculate the total work done on moving it from A to B on the path, A to D on the linear path, and then D to B on the curved path. So here we will calculate the work done on these two paths. Clear? When any charge Q is placed in electric field E, the force acts on it, that is Q into E. Clear? When we move this charge small q in electric field, means if we place it at a different position, E is different one. It implies that the force is variable one. So here what we have to do? We have to displace charge small q by infinitesimal small displacement. And the displacement should be such a small so that the work done, that is for constant force, we can calculate it like that. And then after, by moving it with so many infinitesimal small displacements from one point to another point, for each displacement when we calculate the work done, and then after if we take the summation of all these, we will get the resultant or total work done. Clear? Now see, when any charge Q, that is placed in the electric field E, the force acts on it, that is Q into E. And now if it is displaced by infinitesimal small displacement dr, dr is such a small so that we can consider E as a constant for this particular displacement. Then this is the force, this is displacement, so we can say this is the work done on moving charge Q by infinitesimal small displacement dr in electric field E. Clear to all of you? Now, first we calculate the work done on moving charge Q from A to C. Okay, and then after from C to B. So here, we can write the work done on the path A to C. That is Q integration A to C E dot dr. But see here, electric field of charge capital Q, that is radially outward. So at each and every point on this particular curved path, electric field is perpendicular to the path. It implies that at each and every point, E dot dr, that will be equal to 0 because E is perpendicular to dr. So we can say the work done to move charge Q from A to C in the given electric field, that is equal to 0. Clear to all of you? Now work done to move charge Q from C to B. So again we can write W for the path C to B, that is equal to Q integration C to B E dot dr. So we can write that is equal to Q integration. Now position C, that is at a distance R1 from the origin, and position B, that is at a distance R2 from the origin. So we can write the limits R1 to R2. Now electric field at a distance R, that is KQ upon R square, and in vector form we can write KQ upon R square into R caret dot dr, that is dr into R caret, because here the electric field and the displacement of our charge small q both are in the same direction. So unit vector for electric field and unit vector for displacement, that is considered same one, R caret, R caret. But we know R caret dot R caret, that is equal to 1. So we can write now KQQ into, now integration of 1 upon R square. So that is actually R raised to minus 2. So integration, that is R raised to minus 2 plus 1 upon minus 2 plus 1. So resultantly it will be minus 1 upon R, and the limits are R1 to R2. Now if we substitute the limits, first R equal to upper limit R2, and then after minus R equal to lower limit R1. But due to this negative sign, you can write KQQ into 1 upon R1 minus 1 upon R2. This is the work done to move charge small q from point C to point B. Clear to all of you? So the total work done on moving charge small q from A to B on the path A to C, then C to B. So that is work done on the path A to C plus work done on the path C to B. But A to C, that is 0, and C to B that we derived here, it implies that the total work done on the path ACB, that is equal to KQQ into 1 upon R1 minus 1 upon R2. Clear? Now let's calculate the work done to move charge small q on the path ADB. Okay. Now see, on the path ADB, when we move charge small q from A to D, point A is at a distance R1 and point D is at a distance R2, and path A to D, that is straight line linear path. તો જો આગળ તમે જે કર્યું કે C to B આ પાથ ઉપર ચાર્જ Q ને મૂવ કર્યો ને જે વર્ક ડન કેલ્ક્યુલેટ કર્યું KQQ into 1 upon R1 minus 1 upon R2. The same will be there for moving the charge small q from A to D. So work done A to D, that is KQQ into 1 upon R1 minus 1 upon R2. Now D to B. So jo આગળ આપણે calculate કર્યું A to C, that is the curved path. It is an arc with radius R1. Similarly, D to B, that is an arc with radius R2. So work done to move on path D to B, that will be equal to 0, exactly like we calculated for A to C. It implies that total work done on moving charge Q on the path ADB, that is equal to KQQ into 1 upon R1 minus 1 upon R2. Now here you can see this thing. If we move charge small q from A to B on the path ACB or ADB, the work done, that is same one. So W on the path ACB, that is equal to W on the path ADB. Clear to all of you? Now here the important thing, that is this one, we proved the electric field, that is the conservative field. It implies that work done to move charge Q in electric field from one position to another position, that does not depends on the path chosen to move, but it depends only on the initial and final position. તમે કયા રસ્તેથી એને એક પોઈન્ટ થી બીજા પોઈન્ટ ઉપર લઈ જાઓ છો, that is not important thing. The total work done, that depends only on the initial and final position only. Clear to all of you? So here we can say this thing, the work done on moving charge Q in the electric field over a closed path. Closed path લઈએ એટલે initial અને final position same આવે. તો જો initial અને final position બંને same આવે તો total work done 0 થાય. અથવા તો આને બીજી રીતે એવું પણ કહેવાય કે integration of electric field over the closed path, that is always equal to 0. This is important result.